Okay, good morning, everybody. Good morning, good afternoon, good evening, wherever you're at in this world. And thank you for joining us, Tim. I'm joined by my friend Tim Vale. Tim, if you get hit the next slide, it'd be great. I'll just say next whenever we do the next slide, buddy.
Sure, man.
Thanks, buddy. So today we're going to go through in this webinar, really to talk about not just about how to use application monitoring to find out when something breaks or where something breaks, but to really dive into a wholly other level to start to understand why something breaks, so that you can do some really interesting things and help developers or help your teams or DevOps and whoever that is actually get to the root cause and actually fix things in your applications a lot quicker. And expose this information in much better ways so that we actually get a better insight into the overall quality of an application. And so today we're going to talk about, using OverOps and OverOps data in the context of AppDynamics, which is kind of a fairly popular tool, I'd say, out there in broad use. So next slide, Tim. So first of all, thank you for joining us. Again, my name is Jim Walker. I'm VP of Strategic Marketing here at OverOps, and I'm joined by Tim Vale, a solutions engineer who I've known for quite some time. I know you just said hello, Tim, but say hello again, please.
Hey, everybody.
Nice one, dude. Nice one. So, okay, great. So I'll just jump into this. I'm going to give a little context of the story, and then we'll get as quickly as we can off into the demo. One quick housekeeping item, though. If you have any questions along the way, please do ask them. We ask that you actually dump them into the chat window. My friend Nahal is sitting next to me. We're going to actually watch all the windows come into the chat. If they're appropriate during the demo, if they're appropriate during my presentation, we'll interrupt the flow and definitely answer them along the way for sure. But if not, then we'll actually try to get to all of them at the end of the webinar as well. We planned about 30 minutes to 45 minutes of content just to give you a sense of how long we're going to be here today. And again, thanks for joining. So let's just get started. So when we talk to a lot of organizations, a lot of developers, a lot of DevOps people, the operations side, SREs, we're talking to performance management teams, we're talking to CTOs and CIOs. And I think one of the most telling questions that we ask organizations today is, what is the true cost of an error or a slowdown in their application? And so, Tim, next slide. And so really it comes down to kind of two sides of the same thing. And I think a lot of organizations think, oh gosh, well, if I have an error, it's gonna degrade my brand, right? Like somebody's not gonna be able to access this, or I'm gonna have like some weird, public thing on CNBC that says something bad about me and my organization, right? That's bad brand degradation, right? This downtime, which is I think something we all look at basically avoiding within our systems today, is definitely something that's a big, difficult cost. Can you actually measure the cost of downtime? Yeah, but I think it's different in every organization, right? And I think like this loss of customer, loss of revenue is one of these things that I think is just different everywhere. And so I think of that more as kind of like the soft cost. I know it's a very hard cost to swallow, but it's kind of more difficult to actually calculate, right? And so if you go to the other side of it, next slide, Tim, we start to think about the hard cost. And so what is the hard cost of an error? Well, every time I log an error, there's storage, there is compute, there is network traffic, there's an overall impact on performance. What happens when there's a performance slowdown in your applications? What's happening in the background, and what does that actually cost you from these hard costs as well? And so it's when we think about the true cost of an error, it really comes back to not just the business side of things, but there's actually a cost of doing business as well that is impacted as well. And so we always think about these things, kind of the hard cost and the soft cost of kind of doing business and of errors and slowdowns in your application. So next slide, Tim. So how do you avoid these things, right? Like, how do you actually cut down these issues and avoid some of these costs that you have? Well, I think we've put a lot of tools in place. We have kind of application monitoring, and application monitoring kind of, it appears in many different ways. Like one of these things is things like, AppDynamics. On the other side, it could be things like Splunk or the Elk stack, right? Using these things to actually identify where these issues happen. So you could go and attack them and actually resolve these issues before they cause the soft costs and the hard costs, right? And so what we've realized with a lot of these tooling, though, is that they're really good about telling you when or possibly where something has happened. Like let's point to a point where you could start looking. But when you start to get into the why or the how, this is where things get a little bit more difficult. Like if I'm really going to troubleshoot what happened deep down in the layers of code from a business functionality point of view, I've got to run scenarios. I've got to check code out. I've got to, play around with data. I've got to try to actually understand what's happened in production and recreate a condition. And then once I get that redone, I've got to get it back into QA and make sure that they're testing it the right way. And the variables and the vectors that you have to go down to actually solve one of these issues is often incredibly complex. And some of the most tricky issues we have cause the most amount of time. And let's just take a step back and not even talk about things like uncaught exceptions, which could be causing slowdowns and maybe highlighted in your APM tool, but you don't even know what's happening, right? Until your APM tells you. How do you actually find that that's actually going on, right? And how do you actually correlate a slowdown to something like an uncaught exception? And uncaught exceptions are really, really tricky in this whole world, because these are things that maybe you left a connection to a database open and you have an overflow of memory, right? Like there's lots of different reasons why these can be extremely painful in your applications from an application monitoring point of view, and really difficult from a troubleshooting point of view. So next slide, Tim. Excuse me. So sorry, buddy. I know I'm getting there, right? I only have one couple.
You're there. You're almost there.
Next Tim slide. So thanks, buddy. So I think where people kind of pick up with the when and where things have happened to get to the why and how is they'll start with log files. And so I think we spend an insane amount of time in log files trying to identify kind of more detail and to basically perform forensics, if you will, on what's happened. But log files they're limited, right? Like they're manual. You have to actually tell the log file what you actually want to put in it, right? They're shallow. What people typically publish in a log file is, a couple 2-tree variables, right? And the other end, they're noisy. How do I discern one error from the next in a log file? I don't know. I used to be a coder. I would copy paste code from other people and put it into my own functions. And I'm telling you what, one error is going to look exactly like the other error in a log file until you start looking at that stack. And sometimes the stack looks really close. And sometimes our log files are so dense and so big that to actually perform regex to get to a point in time, or to use one of these tools, to identify like a needle in that haystack, right? To really identify an anomaly, difficult. We don't have a fingerprint for an error anymore, like where we never did. And so how do we actually discern these things? And so these three problems basically kind of is the premise of the entire creation of OverOps. And really, we created a company to basically address the problem of the amount of data that we can actually collect around an error or an exception or a slowdown in your code. So next Tim slide. I'm just going to keep saying it, buddy. So what we've done as an organization and the technology we've created, product we created, is really about capturing net new data from your applications. So every time an error is logged, an exception is thrown, or a slowdown occurs, what we're doing is basically taking a snapshot of what's going on in real time of the software virtual machine, be it the JVM or the .NET CLR. And what we're collecting is some really interesting information. You're always going to get the execution stack, right? That's kind of, we understand that. We're going to take bytecode, translate that back to full source code, but then we're going to overlay the value of every single variable in that execution stack. So you no longer have 2 or 3 variables, you have everything. You have complete visibility, right? We're going to collect the state of the JVM, so the state of garbage collection, all the threads, all the environment variables that are going on, information about the operating system. And so with all this information, what we have is this kind of fingerprint of an error. Now, the way that we do this is unique. We create something called a code graph every time you deploy an app. You deploy an app, and OverOps basically analyzes your code to understand all the execution paths in that code. And we can now take the fingerprint of an error, which is all this data, this wonderful structured data that we have, and we can now map that to a build, right, or to a deployment, right? And so now we know, particularly by release, when an error was introduced or a slowdown occurred, right? Because we had this really great information, this really wonderful structured information. And with that, now we could actually map errors and slowdowns to particular releases. We could do things like take the frequency of how many times they happened, or the failure rate. Do they happen every time I go through that code? It's a really unique approach, and it just really attacks that issue of the noisy side of your log files. If we have a fingerprint of an error, can we do things like deduplicate the amount of events that we're actually telling you about? Maybe we just capture it once and tell you how many times it happened, right? And so it's those kind of things that we're able to do and give you really deep visibility into what's going on in your applications. Now, Developers love this because it's going to help them troubleshoot, and then Tim's going to show you how we can use this in the context of AppD to troubleshoot. But it gets really interesting when we start to expose this structured information around issues in our code in aggregate form, and we feed it to things like, Grafana, or, maybe a Splunk metrics dashboard, or, opening this data, which is kind of the next slide, Tim, into all these other tools, and using this data in the context of everything else is where I think a lot of organizations are finding extreme value from OverOps. Yep, great. You can understand how troubleshooting is a lot better, but using it with other tools, things get really interesting as well. And so today, next slide, Tim, we're going to focus on kind of what we're doing from an APM point of view around AppDynamics. We've made a couple of changes in our product, a couple new features over the past couple of months that allow us to do some cool things. I'll let Tim kind of get deeper into the details. I'm just the marketing guy. But ultimately we can insert links into log files so that when you're troubleshooting, you get links back to us and get complete information. But we're doing other things, and we're instrumenting within these tools themselves to actually understand when they're doing their work, can we actually start to do our work as well? And so I'm going to stop with the marketing side and the slideware and my next Tim slide stuff, and I'm going to let Tim get into a little bit more detail about this and show you guys a demo. Tim?
Awesome. Yes, it's me. You ready?
Take it away, buddy. Yes.
All right. Yeah, so I think, Jim, thanks for setting that up. And I think before I jump right into the AppDynamics stuff, I want to make sure everyone on the call is kind of a little bit more comfortable with what we do. I'm a visual person, and so I thought I'd kind of show you in the tool. I think OverOps is an incredibly powerful way to understand, kind of the unknowns that are affecting your application. And Jim hit on this a lot. It's this idea that your application, the JVM that it's running in, is doing a lot all the time, probably generating lots and lots of errors or events. And in fact, for most of OverOps tenure, we've been focused very heavily on identifying exceptions or errors in your code that are affecting perhaps application performance, but are traditionally leading to something like a stack trace and a log file. And so, this is our overall dashboard. We certainly have other dashboards that Jim alluded to that can be shown in Splunk or Grafana. But the idea here would be, I've got a bunch of events happening. I've got a 404 occurring. It's happened 93,000 times in the last 30 days for an error rate of 20%. It first was seen 2 months ago, and it was last seen just now. That's really important metadata about the history of not only this particular error, but my application in general. But I think where things get really interesting as it relates to OverOps is this ability to drill in to all this great detail about a specific event or error that's occurred in your application. And as Jim alluded to, we're going to show you the stack, right? That's table stakes. That's easy to do. What's not so easy to do, and I think really, really valuable, is we're going to show you the decompiled bytecode, or the source code in a sense, for every method that was executing in the stack leading up to that failure. We're also going to show you lots of metadata, but the real meat of it is this ability to surface to you source code at the moment this important event or error occurred. And not only are we showing you source code, but we're actually showing you full variable states. So the moment this event or exception occurred, I can see the source code, but then I can highlight, hover over, or drill into the actual variables that may have led to this exception or event. And it's not just about variables, it's not just about source code. We'll show you actually the last 250 lines of any log statement, regardless of whether or not it's been written to files. So we have trace, debug, info level statements, and then full JVM state. What was happening in garbage collection, what was happening in environment variables, system properties, etc. But the purpose of this particular webinar is really to talk about AppDynamics. And what that leads us to is this question of performance. So this is great. I can use OverOps to tell me the details about when an exception occurred, but what happens if there's a slowdown in my application? Maybe it wasn't related or created by a series of exceptions. Maybe I've just got bad code written somewhere. OverOps up until now has relied on something called timer capability. Some of you may have seen this, where you can, within OverOps, come in and say, I'm concerned about a specific method in a specific class. And if that method ever executes over a certain threshold, I want to take this detailed snapshot like I just saw for an error, but I want to take it when the threshold exceeds some, or when the duration exceeds some threshold that I've set. And this is really important. Folks are using this very heavily today to troubleshoot performance issues. But the reality is you kind of have to be aware ahead of time where your vulnerabilities are in your application as it relates to performance. And that's where folks are relying very heavily on application performance monitoring tools like AppDynamics. So I want to kind of walk you through how you might link, given some of the new capabilities that we've had, OverOps relative to performance as visualized via AppD. So here I'm sitting in front of AppDynamics. I've got my application, I've got my dashboard, and I noticed that I had a kind of a blip in response time early this morning. Everything looks green now, everything seems to be operating normally, but I'm kind of curious, as many folks are who use AppD, about certain anomalous behavior. And so what I want to do is drill in to maybe understand what was occurring in my system around this time. And so I'm going to select this window and I'm going to view transaction snapshots for this time period. And actually what I'm really interested in is some specific slow transactions. And so I've sorted this list by the slowest all the way down to the least slow. And so this would be, I think, a typical workflow for somebody who is kind of troubleshooting performance issues in AppDynamics. And one of the ones that I was interested in, because I know this is a method we've been spending a lot of time on, is this call right here. It happened at 6:14 this morning. It took about a second and a half, and this is a lot longer than this method should have taken. And so I'm going to click into AppDynamics and look at some specific details here. And so if you guys are not familiar with AppDynamics, this would be a very traditional screen. I'm looking at kind of all the detail that AppDynamics can present to me about this specific user experience, which it deemed to be very slow. And so if I click on the slow errors and calls, you'll see that this get item request took 478 milliseconds. Well, okay, I'm curious about why that would be. And so if I drill down, and I would imagine many of you have done this before, if I drill down into this class, I can begin to see where in particular, excuse me, I just hit the bad button there, where in particular the slowdown is occurring. So if you look through this big, tall call graph, you can see that I've got a slowdown here and a call out to get item in some Amazon DynamoDB calls. Took about 96% of the time that this method took in total was spent in this place here. So if I come back out of this, I have the ability to actually drill in via AppDynamics into some other details. And so if I come back over to this particular method, oh, let me go back here. I'm sorry, I clicked the wrong link. Let me go back, expand all again, and come down into this 92% and look at those details. And again, what am I faced with here? I know that this is the slow method. I mean, that's for sure. AppDynamics has told me that very clearly. But why is it slow? What is it that was happening inside the code that was executing here or prior to this invocation that caused the slowdown? And this was Jim's point earlier. This is a great way to say where an issue has occurred, but this is about as low as you're going to get in AppDynamics with the why. And so this is where our new integration becomes really, really interesting. So we're using a concept called data collectors. If you've not used these before, let me spend a little bit of time and show you. But the idea here is that when AppDynamics is automatically taking performance snapshots, in other words, AppDynamics without OverOps has determined that this is an important event in your application and it's time to take a performance snapshot so that I can do this kind of investigation from within AppD. Now with our new integration, one of the things you're going to have the ability to do is click on the data collector and see something very unique to OverOps. And that is now a tiny link or a link to our detailed root cause analysis. So instead of relying and wondering why this particular method was slowed down, why AppDynamics decided to take this particular snapshot, I now have the ability to jump into OverOps for this specific transaction event, for this specific issue, and I can move directly over to OverOps, and I can paste that link into the URL like I'm doing here and be taken to the root cause of this particular event. And so, the contrast here is, boy, if I'm left only to wonder about the why from these sets of screens here, I'm limited in the information I have. But now with OverOps, being able to leverage the data collector capability, being able to be automatically inserted into the transaction snapshot that AppDynamics has taken, I can actually jump in here and see much, much more detail than I would have previously had access to. I get to see metadata about when and where this application snapshot was taken, what version of the code introduced the code that I'm looking at here, what server was it taken on, what was the IP address. Here's that full stack that we would have seen or do see in AppDynamics. But here again is that power of OverOps and the power of our snapshotting capability. I get to jump right into the source code that was executing at the time this transaction slowed down, at the time this performance issue was introduced. And again, not just the source code. I actually can see the values that were passed in. This becomes so useful when debugging and troubleshooting not only errors, which we know we're very good at, but actually starting to troubleshoot performance issues as well. And that linkage from AppDynamics, using data collectors to be able to jump directly into the root cause of why a slowdown has occurred, is a really, really powerful feature. And this is exactly what OverOps is going to be offering to AppDynamics in the very near future. So Jim, I wanted to pause there. I felt like I said a lot very quickly. Felt like I stumbled over a few things, but that's kind of the gist of our integration and what we're doing here. So maybe you can help me. Yeah, please.
Great job. And there were a couple of questions here, and I think, first and foremost, we got a couple different times here and a couple different ways. It's like, do you have to do anything differently in code to have this all work? Or, and there's another version of the same question, do you have to do anything differently in AppDynamics to have this all work?
If the answer was yes, I think our value proposition wouldn't be nearly as impressive. But luckily, the answer is no. The beauty about OverOps is it does not require code changes to get this level of insight. You don't have to update your build. You don't have to update a jar. You don't have to switch out your logging framework. Nothing. You're literally installing a native agent that sits next to and listens to the JVM, and we're going to capture all of the data that you need. And the answer applies to AppDynamics as well. There's no new thing to do here. There's no significant configuration. What we're going to be doing is listening and borrowing from essentially AppDynamics' decision to take a transaction or performance snapshot. We're going to piggyback on that and take a snapshot of our own using their data collector capability. And you're going to be able to jump right in and link from AppDynamics to OverOps for that specific slowdown that has occurred. So the great answer is no.
Yeah, so basically once they start taking snapshots, we start taking snapshots at the same time, basically,
well,
right?
Yeah, you're absolutely right. And I think maybe something I glossed over, but is really important, is I showed earlier, we had a concept of timers in OverOps, but that was kind of a manual thing. Hey, I've got to go in and I've got to set a timer for this specific method in this specific duration. The nice thing about this new capability is it's really relying on AppDynamics to determine when a snapshot should be taken. So there's lots of configuration in AppDynamics that users have the capability to say, this is what defines a very slow method. This is what defines a slow method. And we're going to be piggybacking off of that configuration that they're probably already doing today, relative to performance. And so it really shifts a lot of the power of configuration and the automation of configuration into AppDynamics and away from the kind of manual configuration you have today with OverOps. So you're really getting the best of both worlds.
Yeah, so let me actually, and that's great. And there was a question here about like, how do we define a slowdown? And I think it's right. Like, let's work the way you work in the systems and the tools that you use in your organization to define what you believe is a slowdown. We don't want to do anything different in OverOps unless you want to add a manual timer like we're talking about, right?
Yeah,
like
exactly.
We do this in our own tool, but like, why not just integrate with the tool you already use to manage slowdowns and let you define it there in the way that you already do it in AppDynamic, and then build off of that and understand what's going on to understand when thresholds are broken or whatever else you want to actually snap from a slowdown point of view, right? And so
that's absolutely right. I mean, OverOps is not telling AppDynamics to make these snapshots, right? AppDynamics is coming to the conclusion by itself. These are the slow errors in transactions. Right. And the key is our ability to leverage that decision that AppDynamics has made and essentially trigger a snapshot via OverOps and present that data via our collector and obviously jumping into our interface. So yeah, this is all, most AppDynamics customers are already using and leveraging this capability very heavily today. And so this is a really nice addition to that.
Yeah, it's just a fundamental approach to the way that we do, we go about building a product. And it's, I think it comes back to this, me, Tim, I always come back, I'm just the marketing guy, but we work the way you work, right? It's like, let's just work within the context of the tools and the frameworks that I think organizations already have. But let's give them some really, really powerful data to actually to make great decisions, right? And so there's another question here, and it's, there was it's all kind of along the same line. I hope I asked the question in the appropriate way to actually consolidate a couple questions down to one. But so in the example that we had, it was like we had the get item function, and you showed the source code for the entire stack.
Mm-hmm.
How do we go about decompiling that, or is that the full source code from our SCM?
Yeah, so great question. So a couple different things. Let's jump back into that snapshot here, right? So maybe spend a little bit of time here. So OverOps, there's a couple interesting capabilities here. OverOps is really good at analyzing code that you have written, right? And it doesn't pay a lot of attention. It can, but doesn't pay a lot of attention to kind of external libraries. Certainly can be configured to do so, but doesn't necessarily. And one of the things you'd see if I toggle this thing right here is that the last call that we made, that our application wrote, was something called get with retries. But if you notice from AppDynamics, the issue was actually buried in Amazon DynamoDB client get item. That's because that's kind of an exit point, right? We called into that piece of code from our code. But this is really, if you're troubleshooting a problem, if you want to have control over resolution, this is where you really need to stop and understand. It's my call in DB Manager get with retries that's potentially the culprit, because perhaps the parameters or values that I'm passing to this particular method are what is causing issues, or those issues are in other pieces of code that I've written that are farther down the stack. And I think that's, again, the real value of not only having the last method in there, but actually full source code and variable state for everything leading up to it. And so in terms of how we get this code, that's another interesting question. So we're decompiling, if you will, the executing bytecode that's running in your JVM. And that's why you may see here some code that looks a little bit different than you might have expected a developer to write it. One of the great news or new features that we have here is this ability to not only upload source code, in other words, visualize within OverOps the source code that I wrote it, but we actually have automated integration with source code providers like GitHub, Bitbucket, and you saw that on the slide. And what that allows us to do is, instead of actually decompiling, as this method was, in fact, if I hover over here, Fernflower was the decompiler that allows me to visualize this source code, but you'll actually be able to pull this source code directly from GitHub. And what's also cool about that is that you're going to be able to then see not only the source code, but now I have access to Git features, right? Now I can run a Git blame to see, hey, maybe the reason why this particular call has really slowed down is that because somebody made a change to this method in the last version of our code. So some really interesting capabilities, not only with being able to decompile, but actually being able to integrate with a source code repository and leverage the functions that are there. And so hopefully that answered some of that.
Yeah, Tim, if I could just pile on, I think one of the most interesting parts about that to me is because we actually know this error, and we know that it was this build or this deployment that actually was that this was a part of. It's no longer like pecking and choosing around in a Git library which version it was and trying to figure out and correlating time. No, we know exactly which build it was, right? And with direct Git integration, we can actually map directly back to the SCM and say, no, it was this. We can say definitively that it was this particular build, which I think is, like, to me, one of the coolest things. Yeah, we can decompile code, but with Git integration, we can actually get back to exactly which branch and which time, which version.
Well,
and so. Big deal.
You're absolutely right. I mean, it's such a time saver because, if I'm an engineer and I see this code, okay, well, this is my code. I know where it is. Let me go grab it. But as you well know, a lot of the use cases of our customers are actually on the operations side, where there may be kind of a big divide or a kind of a wall between developers and operations. And we have operations folks using this that are really shortcutting that whole process of understanding the code that was executing and who might have been responsible for writing it by leveraging the capability that you see here. Prior to OverOps, it was a bunch of phone calls and Slack messages and emails and worrying about, is this developer up? He may be in another time zone. Now I can actually see the code that was executing. I know which version it was. I know who made the change. It becomes really, really powerful. And that's why we're seeing folks really reduce the time it takes to resolve issues, because there's no more of this chasing folks around trying to figure out who wrote the code or what code was even executing, let alone what variables. It's all right here with an OverOps, and I think that's really powerful.
With completely structured information around every error and exception, we now have a fingerprint of a particular moment, it could be a slowdown, whatever that is, and mapping that back to a build is hugely powerful. Then exposing all that information for use in tools like AppDynamics, so you do troubleshooting is cool, but using them in aggregate form to start to understand things like, well, how many new errors are in this release? Using them in the context of CI/CD, there's lots of different ways I think in which that's used, and I think that's where it gets really interesting, right?
And I probably glazed over it earlier, but I think another thing I might add here is that, again, if you think about great, AppDynamics has told me where, but now I've got to jump into the why, and now I see the source code, I see the variable state. But prior to the introduction of this capability, what a lot of users would be doing at that point is saying, okay, well, I know I have a slowdown. Let me jump into my logs. Let me start parsing through logs. And again, I think this highlights one of the capabilities with an OverOps is this tab, this log tab. We've spent a lot of time talking about source code, but for this slowdown, right, I obviously see source code and variable state. But if I click the log tab, now there wasn't a lot of logging in this thread leading up to this event, but I wanted to show it because it highlights another interesting capability. I don't have to jump back out to, another tool. I don't have to SSH into a box and start parsing through log files. The last logging statements that were executed for this thread are visualized via OverOps. And oh, by the way, you're seeing info, trace, and debug statements here had they been written. In production, right? It could very well be, and probably is, the fact that in the production environment for this server, info has been turned off. Trace has been turned off. Debug has been turned off. So you're going to be able to see things from the OverOps UI relative to events prior to this performance slowdown that you wouldn't be able to find in log files because they were never written to disk. And that's kind of gets back to some of the original value prop of OverOps in the detailed snapshot that we take. Now you get to apply all that same value and power, but to performance issues. So it's really neat stuff.
Yeah, lightning in a bottle, buddy. Lightning in a bottle.
I think so.
So I got one last question, and you're probably going to guess which question this is. I think we get asked this. I think every single time I've ever talked to anybody about OverOps and what we're actually doing here. Can you guess? Well, I want to ask you to guess what it is. So what's the performance overhead of all this?
I thought you were going to ask me one of two questions, and that was you actually asked the second one that I thought about. So it's minimal, and that's important because obviously in the real world, performance is king. That's why you have performance monitoring tools like AppDynamics in place. So what we say to customers is between 1% and 3% CPU overhead in production. Negligible, if any, impact in memory, and part of that, and we probably don't have time to go into the reasons why, but needless to say, very safe to use in production environments. We work very, very hard to keep overhead at a bare minimum because we recognize we provide very little value if we didn't, and that has been proven out time and time again by our customers. So you don't have to hear it from me; you can talk to them about that.
Yeah, and so I'm gonna pile on one last thing there. And so at the very beginning of this presentation, we talked about this thing. It was called a code graph, and understanding a deployment or a release, and understanding all the execution paths and what's in that code. Being code aware is what allows us to get this performance, right? It's kind of like before when we drive down the street, we didn't know where we were going. Today we have Waze or we have Google Maps or whatever we have. We actually at runtime. Next to the software virtual machine, so with the JVM and the .NET CLR, somebody actually asked about that as well. We're happy to do it with the .NET CLR as well. It's just less pervasive. We actually understand where we're at in the application, and that's what allows us to do this at such high performance. This is what allows us to do uncaught exceptions because we know we're code aware, right? Because we know what's going to happen, we could say, look, there's going to be an error, there's going to be an exception, or the slowdown is happening. Take a slice of memory basically and start to figure out what that is. Or, this is going to happen, and you know what, a social security number is about to be captured. Okay, redact that information, right? And so because we are code aware, which is unique to OverOps, and I think that's the difference between ourselves and any other thing that's out there doing this level of application monitoring. That is really the difference between what we're doing and the data that we collect versus everybody else. Yeah, we're collecting this wonderful, like, verbose, structured set of data that you can use in lots of different ways. I think it's just the nature of what we do. But this code graph, right? The understanding of the way that we collect this data is really the true differentiator, and that's what allows us to get these performance, advancements, so that we can actually work in production, so that we are under 3% or 2% at steady state. So that because we understand this stuff has got to work. If this was to break an application, it'd be detrimental to everybody involved. So with that, I just want to kind of. I think that was all the questions. Go on, Tim.
Well, I was going to say, the second question we always get, and I'll just throw this in there real quick because I do think it's important, particularly if you've come to this webinar and didn't really have a prior experience with OverOps and maybe you just saw AppD and were curious. So, hey, now this is a new capability in AppDynamics. I was just troubleshooting performance with not a lot of detail. Now I'm jumping in and, geez, I'm seeing code and I'm seeing potentially sensitive data. That's maybe an issue for me in my organization. And so it is important, I think, just to spend a minute and talk about our security capability. So if you do implement this capability and you jump from AppDynamics, now I'm seeing source code, now I'm seeing variable state, we have really, really strong data redaction capabilities in place. So we can redact things like personally identifiable information, social security numbers, credit card information. It's highly, highly configurable via RUI or via REST APIs. So the idea, again, if in fact you're coming here now to this new experience to see this great amount of detail about performance slowdowns, we're not going to surface things that shouldn't be seen to your end users. There's a tremendous amount of control in place to lock down what OverOps can store and show so that your data remains safe, even now with this enhanced capability.
Yep. And then, there was one last question I do want to actually ask him, and thank you, because I think that's a key piece of the overall story. And it's because of the code graph we can do all that stuff, right? And so, last question: can OverOps be toggled on and off? Like, say I want to run a smoke test, or I'm just seeing way too much, I just want to turn it off for a little bit, come back on. Pretty easy. Right?
It is. I mean, there's lots and lots of different ways to kind of throttle the amount of data that OverOps is going to collect. We have the ability to delete or hide things, and then we haven't had a chance to talk, and we should. Maybe in a future iteration of this, really about our alerting capabilities. And so, again, something we take a lot of pride in is sending the right kind of notification to the right place at the right time. And that's very, very highly configurable, more so than I've ever seen in any other product. And so the idea is we don't want to overwhelm you with a bunch of stuff you can't take action on, whether it came from a performance issue or whether it came from an exception or event. You should know exactly where to go at the right time. And we work really hard to do that.
Right. And so coming back, I hope everybody kind of saw a little bit of some insight into, there's the when something breaks and potentially kind of where, but this is a different level of the why and the how. This is getting into the detail and into the nitty gritty. I think there was a comment here from somebody saying, the variables alone just would mean a huge piece to my team from a troubleshooting point of view. And I'm happy that came across. Thank you so much, Tim. It was a really, really valuable demo. So do you want to just go back to the slides? I want to end it up on kind of one or two and just and thank everybody for coming. All your screenshots, all those. There we go, buddy.
Just in case it failed, I had screenshots ready.
Hey, belt and suspenders, buddy. Belt and suspenders.
That's right.
See, you know what that is.
I do.
Thank you. So ultimately, OverOps and the data that we're collecting can be used in lots of different ways. People are using us to deliver better applications. So this entire demo was all about AppD and how we can actually integrate from an application monitoring point of view, expose these things so that we can actually, help organizations deliver better, more reliable code and using our code-aware data to do so. On the other side of it, I think we saw a little bit of this today as well. Improving productivity for developers so that they can more easily troubleshoot issues is a huge value here. So it's kind of interesting for us. We speak to organizations and we speak to all different types of people in organizations, and it's both on the operations side, be it DevOps, SRE, IT operations, sysadmins. They love the information that we're exposing. And then on the development side, man, they sure do love us to help with kind of the root cause automation. And so we're happy to talk to anybody about these two use cases. So next slide, Tim. And then let's just go on to the next one. I spoke about this at length. So, but I want to just thank everybody for coming. Please visit us at overops.com/AppDynamics. That'll bring you to the integration page, of which we actually get into a little bit more detail. We have a white paper that's available. It's a little small tech brief. It's a quick 3 to 4 page paper that we'd love for you to download and read and pass along to your friends. You can sign up for the free trial. This webinar will be available to everybody. I know Nahal. Thank you, Nahal, for organizing everything. Can you say hi?
Hello, hi everyone. Thanks for joining.
I need your voice in one of these times, right? So we'll send the webinar and the link out to everybody. If there was any like uncaught questions, you like my uncaught questions? It's like an uncaught exception. If there are any uncaught questions, I will surely try to get those answered and sent out to everybody. But I'm pretty sure we hit everything. So with that, again, thank you for taking the time out of your busy days to join us today. I hope this was valuable to you. I hope you saw how, I think there's a lot of tools that are going to help you with the when and where, but with OverOps, getting to that why and how is such a key piece of this overall process. So thank you, Tim. Thank you, Nahal. Thank you, everybody, for joining us, and please have a great day.
Of course. Thank you. Bye.